So here's our last note for Unit 7, solving, graphing, and verifying complex inequalities. When an inequality is multiplied or divided by a negative number, the inequality sign reverses. This is where things get tricky. I'm going to do the exact same question twice just to show you what happens. Now in this case, I have 2a minus 5 is greater than 2 plus 3a. I'm going to move the 2a by subtracting 2a from both sides to get the variable on one side only. And that gives me 3 minus 2, just an a. I can subtract the 2 from both sides, and you've done lots of these types of solutions so far. And negative 7 is greater than a. But what happens if you did it differently? What happens if you subtracted the 3a because you like to have your variable on the left-hand side? 2 minus 3 is negative a, the invisible 1. And then you add 5 to both sides so that you can get the a almost alone. It still has the negative sign. Now you can't have negative a, so you have to divide by negative 1 and divide by negative 1, and you get a and negative 7. Now I want you to think about this for a second. A in this case is less than negative 7. Well, you can't have a different answer. A has to be less than negative 7, but this says greater than. If you divide by a negative number, so if you divide by negative 1, then you have to reverse the sign. So if it was greater than, it now has to be less than. So a is less than negative 7, a is less than negative 7. So you have the same solution for both of them. And that's why you have to reverse the sign if you multiply or divide by a negative number. Now we're going to do some examples. Let's start off with negative 7x is greater than 21. To do that question, you know that you divide both sides by negative 7. And you get x and negative 3, but here's the trick. You divide it by a negative number, so the signs reverse. Because you divide it by a negative number, you have to reverse the sign. And then it's the exact same thing, guys, as the last unit, or last note, not unit, we're in the same. You have to check the starting point and the direction. And you'll see in this note why checking the direction becomes so important. I said in the last note it didn't seem very important, and it seemed pretty clear, and you like, why am I doing 2 checks? You'll see why you're doing 2 checks now. So I'm going to check the starting point, negative 3. Negative 7 times negative 3 is positive 21, and it works. Now here's where it gets tricky. You are checking the original equation. Negative 7 is greater than 21. But when you substitute in, you're checking the solution. X is less than negative 3. So I'm going to check negative 4 because negative 4 is less than negative 3. 7 times 4 is 28, 2 negatives, so it's a positive 28, and 28 is greater than 21. You're dealing with 2 different signs. This is the original sign. That's what you have to use. But choose a number that fits the solution. -4 is less than -3. So that's why you chose -4. You're using the equation for your left side, right side, but the number you substitute has to come from the solution. It's tricky. And then you graph it. Are you graphing the equation or the solution? You're graphing the solution. So the starting point you checked was -3. It's an open circle. X is less than -3. And again, I made a mistake and you couldn't see it, but now you can see it. And I want you to graph the solution. And the solution was x is less than -3. Don't graph -7 is greater than 21. It's not what you're graphing. You're graphing the solution. I know I've said that about 8 times now, but it's super important that you realize that. Okay, let's turn the paper over and we're going to do 2 more examples. It won't take too long because you know the arithmetic of this. We're just working on the checks and what the solution looks like. So if I'm dividing by -4 and my is greater than -3, I'm going to have to multiply by -4. I switched to red so you could see which number came first. The negatives cancel just like they've always done. I multiplied by a -4. -4 and -4, so the sign reverses. Now we're going to do the check. When we do the check for the starting point, it's not complicated. It's just like doing a check for the first half of this unit. You're just going to substitute in the 12, divide by 4, -4, and then you get -3, and they match as long as you've done it all correctly and haven't forgotten a negative sign. But when you go to check, remember, you check the original, so it's x divided by -4 is greater than -3. What you choose to substitute has to satisfy the solution. Now this says x is less than 12, so I could choose 11, but 11 is really hard to divide by 4, so I'm going to choose 8 because 8 isn't hard to divide by 4. And I get -2, which is greater than -3. So I chose 8 because it is less than 12 and can be easily, because everything can be divided, but this can be divided easily by 4. Avoids decimals and all those kinds of things. Are you okay? Now, of course, we have to graph it, and you've done tons of this now. So we have the number 12. Line. There's where the 12 is. It's an open circle and x is less than 12, so it goes to the left. Open circle because it's not equal, and to the left because x is less than. Okay, and one more question and we'll call it done for our very last note for this unit. Negative 2x plus 5 is less than or equal to 3. So I'm going to subtract 5 from both sides. Negative 2x is less than or equal to negative 2. I have to divide both sides by negative 2, so the negative 2's cancel. And I've got x, and I've got 1, but I divide it by a negative, so x is greater than or equal to 1. Now here's the trick. That is subtraction. It is not multiplying or dividing by a negative. Do not reverse the sign. That's the biggest mistake. People subtract and then they think they have to change the sign. No, this is division by a negative. Then you do reverse the sign. Now normally I do the check beside the equation. I can't do that for you now because I've put red all over the paper. So we're going to have to slide our paper up so everybody can see. And I'm going to do the left side, right side check to see whether my starting point 1 is correct. So negative 2 times 1 plus 5. Negative 2 plus 5, 3. They match. So it's correct. And then I do left side, right side. Negative 2x plus 5 has to be less than or equal to 3. You're checking the original equation. Negative 2, okay. X is more than 1, so I'm going to check 2. Negative 4 plus 5 is 1. 1 is less than 3. So that's correct. Then we graph it. With a ruler, and you're graphing the solution, so you've got a 1, and it's a closed circle because x is greater than or equal to 1, because you're graphing the solution. And that was that. Now, your assignment sounds a little bit longer than the last one. It's not really that much longer, guys. Page 305, number 7, 8, 9, 10, and 13. Here's what I want you to remember. Just like I said before, when you go to do the work in the textbook, do not check 3 numbers. Only check 2. Also read the directions because you're not required to check all of these. You have to check number 7 and number 10. For 8, 9, and 13, you're not doing checks. You could, if you want, try number 11, but that's only if you have time and you want to. There you go.